Awesome, nice. And please, can you see my screen? If you could please help me notify on the screen, please. Okay, super cool. So thank you so much. And it was really nice meeting you last week on like the first session in which we introduced you to like how the overall structure of this cohort deep learning will be like. And it's also another pleasure to see you again this week so that we could start moving things forward. And this week, it's a bit more of like another kind of introduction, but a bit in-depth to show you what Pytorch is and to kind of dig deeper into what you'll be working with in Pytorch. So before I start in today's tutorial, I'll just like kind of still give you an overview with regards to like the assignment and what to expect. So yes, let's see. So this is like just a bit of a very narrow table of contents in which we'll be covering. So I would just like to go over like the courseworks again, just briefly, just so that you have an idea of what to do after the session or what to submit or what not to submit. So as we discussed, there will be like some courseworks in which you will be doing and you will need to submit them. And it's been updated on the page. So this is the link. So don't too bother about it. If you haven't seen the repository, it will be shared to you just maybe after the session. So don't bother too much about it. So this is like the repository we'll be using. As we discussed, there will be two major parts of this deep learning. So this is the first part, which I will majorly be taking, which is deep learning with Pytorch. And inshallah, next, after this session, like which is like a few weeks, Dr. Shamsu will take the NLP with deep learning, which will be coming in some few weeks, likely next year, more likely next year, yes. So this is just like an overview. So when you kind of go into this particular part, which is the first part, you will see it's kind of arranged in which in the first subfolder, there is the submission exercise. I'll just touch that in a moment. Then apart from that, you find other subfolders which are in weeks. So this kind of outline, this week's just kind of give you more detail of like each of our sessions. So in each of our sessions, there will be like courseworks and there will be additional courseworks. So I'll also tell you why in a moment there will be additional courseworks. So when you click on it, you will kind of see some available content in each week. So in each week, you have like maybe just the exercises for that week, which you will be working on. And for this week, you have like an additional getting started markdown. So this markdown is just to set an introduction file for you to install Pytorch on your maybe local computer or let's say on your Colab. So I think, please, can we kindly mute our audio, please? And yes. So just to, okay. So I think I could go into this just briefly, just explain to you. So as I say, like for this week, we have getting started. So I'll just go over it slightly and exercises also. So for the exercises you have, so for the exercises majorly, the exercises are pointed towards like the Learn Pytorch for deep learning, which we talked about last session, which will be your major reference point for this particular like tutorials, inshallah. And there will also be additional exercises. Why will there be additional exercises? It's because like in this particular material, there are exercises and there are solutions to exercises. So it's very okay for you to answer those exercises, but we really want you to learn to build your skills even more. So the additional exercise is for you to like work harder towards what you've learned and utilize it more so that you will be able to build very solid skills after the entire session, inshallah. So like I said, like here, there are solutions for it, but I won't advise you to look at the solutions, except if you are really it's giving you tough time. And even if it's giving you tough time, your colleagues and I are always around to help at any point in time. So the additional coursework is just to reinforce what you've learned and a bit more advanced than the normal coursework, which will be updated in time, inshallah. And so in this subfolder here, you have this exercise submissions. So we have a template in which you could use to make your submissions. So it's just very basic. Don't worry about it. So you have like your exercise for the solution and the additional exercises in which you'll be required to submit, inshallah. So I think that's majorly it for with regards to coursework. Let me just say assignments. So and every week there will be like assignments, and we expected to submit the assignments like the coming Saturday, inshallah. That's by, let's see, by midnight. Let's see, the assignments after for today, you will be expected to submit them by next week, Saturday, midnight. Just to bear in mind, like, since most of us are a bit busy, so you have like enough time. And the assignments, believe me, it's not something really complex. You would likely be able to do them in one day, so you won't have any issue. So in the case like the assignment gets really complicated, we know how to extend the assignments. So to not, yes, so I think I'll just like head on with a few Q&As. So please, in the chat, make use of the chat. I just want to kind of know how, like, the audience you are dealing with, so that to know how fast-paced will go in the course. So please, has any of you like used Pytorch or any other deep learning library before? You could just comment yes or no. It's no big deal. If you have, and if you have not, it's no big deal. Just know how to modulate the speed of these sessions. Okay, nice. Okay, cool. Cool. Okay, thank you so much. And so I know, like Doctor mentioned, like most of you are from the previous cohorts and you've done GitHub. So please, can you also indicate if you have idea of GitHub? If you don't have, you shouldn't have any problem. We could go over it again, just to have an idea of the audience with who I'm discussing with. So don't have any fear. And it's better to indicate if you don't know, so easily we know how to go about it. Great. I think almost all of us have an idea of GitHub. So super cool. And I think I would, yes. So if you want to get started with Pytorch, I think since about maybe 20%, 25% have not used Pytorch before. So I think firstly, I'll just, in less than 10 minutes, I'll just go over like an installation guide to help you install your Pytorch on your local like environment. So just briefly, I would just, let me just create a new window. So, let me see. So let me just start here. All right, okay, let me just take this. So don't bother too much about this extra information. I will just take them out. And so please clarify if you could see my time now, right? On the VS Code?
Yes, sir.
Yes, nice. Thanks so much. I just want to clarify so that no one is left behind. And yes. So this getting started is just like a very small guide in which you can install like what's the name, Pytorch on your local environment. So here, what you do in the first case, you create a Conda environment with the name deep learning. It could be any name you want. You could assign it any name. And the Python environment, you could use like any Python version you want to use. So I believe maybe most of you have used Conda. If you haven't used Conda, Conda is just like an environment management system. It's really good if you are really working on different projects to help you like segment your work and work in a single silo environment, which won't interrupt other of your projects. So I think firstly, we just create a Conda environment. And it just takes a few seconds to create. And the next step is just to kind of activate your environment. That's more of like just entering into your environment you have created. So here you could see like the environment has changed from base, which is like the default environment in Conda, to deep learning, which is the environment we have created. So here you could see like a line in which you could install your Pytorch and like some sub-components of the Pytorch in which would be beneficial to you when running your projects. But if you do want, you could just install only the PyTorch without like the subcomponents of the like touch vision and touch audio. So, and this -y here is just a flag to indicate that it should automatically like accept any kind of queries, because there is like the yes or no questions that comes in when you're installing packages. And I think just takes a few moments to, and I think it's done already. Then you could just, let me just check the, okay, so you could, let me just go to a Python terminal and maybe import touch. And easily you could just maybe, touch is important, you just check the version to verify if everything's okay. So here it installs version 2.1.1. So I think you're all good to go. So you could also look at the GitHub page to just see how you could easily set up. Then let me just cover one small thing after that before we just officially get started with. So there's this link, which is also in the Markdown file there, if you go to the repository. So here, in case if you're using a laptop that has like GPU enabled, or you want to use other functionalities, you could just go here and like kind of choose what's your system like requirements or system specifications are. So here you're choosing Python. If you want to download in a Conda environment, you could just click on what suits you. Let's see, you are using Linux, and for me, I have like a CUDA of version 12.1. So you see it quickly change and adjusts for you. So easily you could install this. So, but if you are using, what's the name, Google Colab, you don't need to worry about this. It's already pre-installed, except if you want a different version compared to what's on Google Colab, which we are kind of going across now completely. So this is basically how you could install like PyTorch on your local laptop. So if you have any issues, just reach out on the channel or reach out to me directly, inshallah. So I think that's majorly it. So I think for now, we will just head out to like the main part of this session, which is like teaching you like PyTorch fundamentals. So like we said, like this is the major resource for this project or for this course. So, and everything we do, we reference this, and anything additional, we will discuss it. So, but within this like sessions, I will be giving like more details. I won't be, because it's like an already established material. So I'll be giving you like a different understanding or different insight so that you yourself could go through the material, understand it differently. But I'm giving you like more hints and more explanations with like real life applications of why things are this way and why not the other way around. So if you have any questions, please just interrupt me or send in the chat. I'll be very happy to answer. So just quickly, I know we are ahead of time. So this is like my Colab environment. So I could get started with like the very first notebook, which is more of like fundamentals. So just briefly to highlight to you, PyTorch is just simply a tool used for building like deep learning solutions for training the machine learning algorithms. So PyTorch was initially built by Facebook, which is now Meta. So, and it is widely used between the research and industrial communities very much. But apart from PyTorch, the reason we are using PyTorch is because of the wide acceptability, and it's very Pythonic in nature, in which if you come from like a NumPy background, it will be very easy for you to adapt to using PyTorch. And since most of us here have like been working with machine learning, so it's easy to like get started with PyTorch. And yes, so what I wanted to say is like there are other vast number of like deep learning or machine learning libraries. I believe you use some, which is the sklearn. But in this category, in like when you are doing deep learning, like the more common ones I would say are TensorFlow, but more recently there is the JAX built by Google DeepMind, which is gaining really tremendous adoption in the industry. So why is that? When you look at Google products such as the Gemini, currently like a version of your GPT-4, so it's built entirely, almost entirely, I would say, with JAX, and even like the reinforcement learning libraries of Google. So I'm just telling you this, like there are different tools you could use, but there is like trade-offs between those tools. So you should be able to know when to use what and what time to use what. So I'm just saying this just so that you should know and you should be maybe open-minded. So what you learn here, it's easily applicable to JAX, but JAX might have like other additional layers in how they implement it. So which is like good for you to know now. So I will just briefly run these notebooks and kind of give you explanations along the way. So if there's anything, please just interrupt me. So one of the very first steps for us here is importing your Pytorch. So easily we understand how like importations work in Python. And Python has, with most other libraries, they have this simple kind of, will I say, attribute, which is version to get the version. So what currently, okay, let me just switch on my GPU. Okay, I think I have GPU, yes. So let it just load, yes, nice. So what this is telling us is we have this installed, Torch of version 2.1.0. And so because in Colab, you have access to GPUs. So GPUs use kind of CUDA. They are like kind of the interface for you to work with GPUs so that you could get tremendous computing power. So here what's telling us is I have it's like a Torch, but a version that uses CUDA. So here is like shortened to CU. So this 2121 is more of like your version for your CUDA, will I say your CUDA system. So you have like various versions, which is 11.6, and here this is like 12.1, but it's made simply to be 121. So don't too bother about that. And in most cases, if you are using your local environment, which is your laptop, you might not have CUDA, then you won't mind seeing this, which is not a problem. Only such that you won't have like computing power. So, which is majorly that. So one key thing about working in deep learning and in most times machine learning, you have to deal with tensors. So tensors are more of like data structures for storing your data. You know how you do have integers, you have dictionaries, you have lists. So you could take these tensors as an advanced form of, we could say list, for instance, but it deals with when it's more effective when you really want to store really very large numbers, and it helps you in efficient and effective computations of those large numbers. So it's more of like a uniform way of representing your data in some way. So you could say like an array is a form of tensor, but anything could be a tensor. So we would also look just subsequent later on in this, we will also look at how the dimensions of array and why do they matter. So in this particular picture, you could see, let's say a picture, which is like an input to, we could say a neural network. And you know how an image is, it's a bit pixelated in which you have pixels. So those pixels that you could see, they represent some numbers. Or when you see an image, it's more of like an image, it depends on the type of image. When you have a black or white image, we say it's a one-channel image. So easily you see it like the colors or the values, even though they vary from 0 to maybe, let's say, 255. So they just present black and white, the variation between black and white. But like in like the image of what you are seeing of me now, it's more of like a 3-channel image, just to make it more colored. So that's what you could see. So you have the RGB. So it's more of like red, blue, green. so channels. But each of these channels have numbers. So those numbers are represented with tensors, which are then computed in any maybe deep learning or machine learning system you want to work with. So this is just high level, so I won't go deep. So in your spare time, you could maybe read the resource and get more information. So I'll just kind of briefly go through it, give you more intuition of why things are what and how you could best work with this kind of systems. So like I said, tensor is just like a data structure. You know how you easily create data structures in Python. Maybe you could say list and just open your bracket and put in some values there and easily you create list. So these tensors too in Pytorch, you could easily create them with a method dot tensor. So here we are going to look at more of creating tensors. So as I said, tensor is just a data structure. So with your tensors, you could create like different dimensions of the data structure. One of the simplest data structures or dimensions you could look at is like the scalar system. So you understand from your physics, like scalar is just magnitude, no direction. So it's just like a single value, which maybe you could say is dimensionless in most cases. So it has like 0 dimension. So here we are looking at how you could create a scalar using Pytorch. So easily you kind of type out torch, then you call out the method of tensor. So you could see it with the number 7. Then easily it kind of creates a tensor for you, which you could access and use at any point in time. So if you do remember, we talked about dimensions. So dimensions in the sense that scalar values have no dimensions. So with Pytorch, you could easily like check these dimensions and work with dimensions in case you want to utilize it. So how could you check dimensions? You could use the ndim. That's more of like n-dimensional. So you want to access the dimension value of the tensor you have created. So running that, it gives you a value of 0. As we said, like what's the name? Scalars have no dimension. They are just single values in which you could just easily use and manipulate. Yes. So they are just like magnitude values. So, and let's say you could see like easily like this tensor here, it returns to you a value of like tensor 7. But what if you want to utilize like these values in your Python operation? Let's say you want to get the actual value, which is 7, and utilize it in an operation. Let's say this is like the percentage or accuracy of your model. How could you access that value? So you could do that using .item. So .item returns the value of your tensor for you, and you could utilize that value for your everyday operation in Python. So what you could do, let's say, you could kind of say maybe print something of maybe I have already a value of 10 plus what's the name? You could say scalar dot item. So why please can we be on mute, please? Just so that we don't interrupt others. I can hear it's echoing. So and yes. So I think that's majorly it. That's like Python. Then you have vectors. So vectors are like one-dimensional arrays. So one-dimensional arrays indicates that they are more of like lists of numbers. So lists, but they don't have like any hierarchy. So it's more of like overlaying. Let me see if I could just easily draw something. Yeah. 1 minute, please. Okay, so So, so we have vectors. Vectors are more of like when you combine several maybe scalars, or you combine them together, so you get a vector. An example of scalars and vectors is if I ask for the age of maybe let's say Muhammad, and he tells me not age, let's say height, and he tells me he is maybe 6 point something feet tall. So that single value is more of like a scalar. But when I ask what's like the height of everyone in this call, and maybe you give me maybe 7 point something and like several values, so that itself, we are only considering height, and I have the height of up to like, let's say 13 or 11 people, so that consists of like a vector in some sense. So that's just, I wanted to like give an illustration with drawing, but like I couldn't connect with my other device. So it's also a tensor. So everything in Pytorch, you can refer to it as a tensor, but on the line, like this is scalar, this is vector, this is an array. So when you extend beyond like scalars and vectors, what you deal with is arrays. So we'll also treat that, so you shouldn't have bother. So just how we created like the tensor initially, you could also create the tensor with vectors here. So, and as I said, when you want to create any tensor, you call like the .tensor method. And if you want to see what you could use for what's the details of this method, you could just do this. And let me see, so it has this. Yes. So by the right here, you could see a docstring, which describes to you what this tensor method is accepting. It accepts data, D-type device, and a whole number of things. So don't too bother about it. Just be more informed on the data. So you could pass in a number, a list, or like a list of lists as data, and it converts it into a tensor for you. So just hold that information for now, and we'll work with it very much later on. So as I said, like with the ending, it gives you the dimension of like any tensor you have. An item, you kind of retrieve a particular value from a tensor. But this only happens when your dimension of like the tensor is 0. That's a scalar for only scalar values. So we just try them so that you see it doesn't work for let's say vectors or values that have higher dimensions. So you could see, let's do something like this, vectors. And let's get maybe the item. So you could see it leads to an error. So you could only get an item for a scalar. So that's just what I want to emphasize. So, and when we could get the shape of like a vector, here with this vector, it's telling us like the shape is just like 2 elements in that particular vector. But let's see if we increase the size, let's say put in more numbers, you could see like the size of our vector has increased, but the dimension is still 1, because let's say in this case, you remember the height example. So it's still, we're just considering one kind of we're considering kind of one quantity in this sense. So, but when you check the shape, you could see like there's a change in the shape, which measures like the more of like counts of items in that particular vector. So that's easily it. And we could easily extend this to like matrices. You know how arrays work? So arrays and matrices are the same. So it's just like convention. So here you could create matrices or arrays in Tensor, in Pytorch, using still the tensor method and arranging it in this manner. So this is more of like a list of lists. So the first row here is similar to like the first row you have when creating an array. While the second row here, it's like the next subsequent row of your array. And passing this to your touch.tensor easily creates it for you here. So, and you could easily check the dimensions of this. And you could also check the shape. So what does this shape imply in when you are dealing with matrix? It's telling you like in the rows, you have like 2 rows and 2 columns. So you could easily like kind of add values here to just see, does this explanation add up. So I'm just putting in some random values here. So here you could see like we have 2 rows, which is this, and how many columns, which is 3, which is this, and this. So you could also like check the shape again, and you could see easily you have 2 rows and 3 columns. So easily, which is easily extended to this. So for the sake of time, I will just briefly go through some things. So as I said, so when you have like more of like the list of lists, so you know how array works, you know how scalars work, you know how vectors work, you know how arrays are and the size. But like in real world, like those dimensions can be really higher than, let's say, 1, 2, 3. So let me give this particular example. Remember I said like scalars, you just deal with maybe one quantity. Let me see, maybe let me say the age of Bala. So it's just one quantity, but the age of you all, it's more of like a list of that same quantity. So it makes it like one dimension. I'm just considering all our ages. So when we go higher to 2 dimension, so if you look at an image, you have like the height and you have like the width. So you are considering 2 dimensions in this case, where you have like the height of the image and let's see the width. And in each point in that component, you know, your image has pixels. And let's say you could kind of give a position to all those pixels. Let's say along the height and along the width, you could give like 0, 0. You could kind of give like an axis to that image, because when you look at the image, you could put your X and Y axis there. So you are considering like 2 dimensions. So when you give me an image with just 2 dimensions, I could locate any pixel within that image, which is the explanation. But let's say we are looking at a video. A quick question to all of us, like how many dimensions can we see like a video have? You could just easily, please just type out quickly in the chat. Let me see. Okay, it seems there are some. Yeah, so when you look at like a video, easily, what can you see? What's the like dimensions of a video? You understand, I said like an image has like 2 dimensions. You have like your X and Y coordinates in that image. So when you look at a video, how many dimensions? Just give any guess. You are never wrong. So I'll just maybe explain after it, and you could. How many dimensions can we represent an image as? I'm just keeping my eyes on the chat to see if there are. Yes, you could say L and H, but more of like in terms of numbers. So you know, an image, you have, let's say, length and height, which is 2 dimensions, which we are considering 2 quantities. But a video, how many? Not really. You can't see. Let's say a normal YouTube video. Just give a number. Like in the image, you have 2 dimensions. You have like the height and width. So maybe let me just say this. So when you look at not really pixels, you know, like when you look at 1 minute, let me see. Just 1 minute, please. So it's more of like, let's say you're considering a number, and okay, I wanted to write. So when you, okay, awesome. I think Sani got it right. It's 3. So let me just easily see if I could just annotate here. So let's say you have, let's say this is an image, right? So you could break down this image into, we call them pixels, but they are maybe smaller than that. So when you look at this, maybe I could just say this is my X-axis, and when you look at this, I could say this is my Y-axis. Maybe I'm saying maybe this is 0 to maybe, let me say 5. Let me say this is 0 to maybe 5. So if you check here, there are like 2 dimensions to any image, assuming this is my very simplistic image. And at any point in time, I could know this pixel here by knowing like the values of the axis. So yes, maybe you could say 0, 0 for this pixel. And maybe I'm looking here, I could assume it's maybe 3, 2. So here we have like 2 dimensions. But what is a video, which is more important to consider? So a video is more of like a collection of images. You have, just look at a video, for instance, like you watch 1 second, you watch the subsequent seconds. It's more of like when you have several images combined together, you get a video. So, but we say it's a collection of images, but along what? So along time. So that's like the interesting thing to know about video. The dimension is 3, because like when you look at it, you have like an image, but it's running across what? The dimension of time. So it becomes like 3 dimensions. So that's why it's good to know the notions of dimensions, because every data set has like a different dimension. Because I believe mostly, let's say you have dealt with tabular data before, let's say the iris data. So those have like 2 dimensions. But when you begin to go a bit advanced, you begin to get like really huge data sets, or kind of different data sets that have different dimensions. So knowing these ideas of dimensions help you to know how to work with this. And please, if it's not clear, just you could, or have any questions, just please, we could go over it via chat. And maybe, I know time is maybe against us, and we could, let me see, how can I clear this? Okay. Let's see. One minute. Okay. So thanks so much for your input. It's super cool. And yeah, so I'll just like go on. And please, if you don't understand, please let me know anytime, and happy to explain more. So those are like the kind of ideas behind dimensions. So it would be nice to have always like learn about it or go over it again. So I've explained n dimension in which you could easily check your dimensions and the rest. So I'll just a bit slightly speed up because of time. And okay, I think there is more explanations here. So as I said, like this session is more of like teaching you the concept, but kind of bringing examples from real world examples, just so that you could make use of it, so that even when you go through the material again, it will be like super easy for you. So next we will just deal with random numbers. And random numbers appear almost naturally. But when you look at random number, it's more of like, first, what's the definition of random number? A random number is more of like numbers that you can't easily predict. So things appear randomly in nature. For instance, we could say, what's a bit random? Yeah, it's difficult to give an example of random, but lots of processes are a bit random in nature. So they kind of, it's a bit unpredictable. So it kind of deviates from what's natural, because let's say as a human, if you look at a human's age, you could say like your age kind of increases from you go H1, H2, H3. It's more of like continuous in nature. So, but random numbers kind of, it's you can't really predict. The pattern is a bit ambiguous. So it's very much useful in like purposes of security. Like when you want to secure a system, having those like random situations is good. And randomness, again, it's good in training neural networks. So easily you could initialize the weights of your neural network with random numbers, and it kind of helps you have more stable training and maybe faster convergence in some cases. So here I will just outline how you could like get those random numbers. So one thing you could know in computers, you can't really get very real random numbers. What you use is pseudo-random numbers. You kind of more of like a false random number, because like it's not really working in real life. One of the approaches you could use is like, let's say you have a laptop computer, the heat from that laptop computer, it varies with time. So, but you can't really predict how the heat happens, even though, let's say you have the same application running on your system. So the heat generated from the motherboard varies. So it's more of like a random number, but a kind of false random number in some sense. So that's how like most of these random numbers that you use on your computers are kind of generated. So here, how could we create random numbers in Pytorch? You could easily call like the .rand method here. and give it a size. So this size is more of like, you know how we discussed about the shape of a tensor. So when you give it a size like this, you tell it you need a random number of 3 rows and 4 columns. And when you try running it, it gives you like some values, let's say between 0 to 1. And when you repeat that again, just pay attention closely to this maybe first number here in the first column and first row, first column, which is 2993. But let's say when you try running it again, it gives you a more different number. So that's like the beauty of randomness. You don't often get the same thing over and over again, but you could get the same thing. That's when you set the seed. We call it seed because you know I told you like it's a false kind of random number. You know, true randomness, it doesn't really occur again and again. But in this kind of scenario, when you set the seed, so you could get reproducible random numbers. But maybe we'll go after that in just a bit. And please, Bala, remind me, this session is 1 hour, right?
Yeah, it's 1 hour, sir.
Okay, nice. Thanks so much. So, I think I'm a bit slow. So, okay, super cool. And let's see. So, yeah. So, I'm guessing you've worked with NumPy. So all these are made very much similar to like what you have in NumPy. You have your zeros and your ones. Just because of time, I think, please, I'll just speed up this. And maybe I will kind of discuss more to see how best we could go on with this session so that it will be much easier for you and will be time efficient. Since maybe I'm explaining maybe too much, maybe I'm not sure. So you also have what you have here, which is a range. You know how you have in your Python where you have your range, where you could do a for loop and you have your range, in which it generates a set of numbers for you from starting from one range to another. So this is something similar. You start from one point and it ends at another point. Then you could kind of add another, what's the name? Another value, which is step. So another parameter, which is step. And with step, like you kind of have, you start from a value, and that step is more of like the interval between the initial value and the next value, or any value and the next subsequent value. So that's majorly it. And you could see that here with range and with a range, you could just easily see like the difference. So let me just, and yes, so I think maybe I will just sunset on these data types, and I'll just sunset on these data types just so that you could look at it again. But it seems we have not really more, but I believe like anything else in this notebook, you could go over it. And if you have any challenge, please just let me know and we could just have discuss via chat and let's see how things go from there. And I think from this session, I will be able to recalibrate, and with the forms, I will hear your feedbacks and see how best we could go about this, please. So with data types are they just describe what particular kind of data you have within your tensors. When in Python, when we say a data type, you could have like a dictionary data type or a list data type. It just explains like my data structure, like this is a description for my data structure. So in tensor data types, you could have like data types of float 16 or half, or you could have float 32. What does these numbers mean? These are like precision values. So when you have like a float 16 has a range of values. More of like with float 16, it creates a memory for you in your system. And that memory has like a length, a size of values it could accommodate. So one thing you should know that with float 32, it's much more precise than float 16. So I'll just give a simple analogy in where each of them would be important. So let's say you are building a system, machine learning system, which is not so, you don't really care how precise that system is. Let's say I'm predicting the accuracy of let's say I build a deep learning system that predicts whether a plant has a disease or not. So I don't really care about accuracy to like to a very high power. If you give me the accuracy in form of like integers, I'm good with it. So in this particular case, you could leverage data types or numbers that have like very small memory size. So, but when you are dealing with a case of, maybe in case of healthcare or maybe quantum systems, so there you need like very precise systems. So here you kind of try to use like uh like uh arrays that have like really large memory that could hold like very large amount of numbers. And one brief like issue you might have is when you are choosing like float 32 or float 64, it kind of, you have more of like more overhead, and it requires more computation because you're dealing with very large numbers. So I think that's maybe briefly what I could say about that for now. And okay, I think these are like some few resources you could read out and check out a bit. So just briefly, I think I would just sunset a bit here. So even though it's maybe half of the resource, or not so much half. So I'm guessing like something you could do over again, but I think we'll get to discuss with everyone and how to best go about it because the material itself is a bit lengthy. Yes, Bala.
Yeah, I just wanted to ask a question with regard to this data type that you talk about.
Yes.
I saw there is a place written touch.cuda. Is CUDA also type of data type, so it's just processing power?
So CUDA, let me see. I can't really 100% say maybe CUDA is a data type. It's more of like when you see CUDA, it's more of like where your data is stored. But like we said, like data types are more of, yeah, I wouldn't say 100% it's like a data type. Honestly, I don't know. But when you see touch.cuda or your data has touch.cuda, it's telling you in which particular memory your data is stored. So as we said, you have your normal like laptop in which you have your CPU and you have like your GPUs in which it's your computation. It's much more faster for you to save your data on GPU. So when you store your data on GPU, that's where you see touch.cuda. So when you try to like print the description of your data. So I think that's what I can majorly see, but I can't really 100% say like touch.cuda, it's part of your data type. So I believe maybe data type should be more of like you have your integer or float data, something of that nature. So I think that's maybe what I can say, but I will make more research on it just so that you could know. But this is what like I could say from my end. So please, we'll just maybe stop here based on this. And if you have any questions, please you could see them. And we'll also share the forms, please, because we it's like a new program and we want to adjust everything just so that you'll get the best out of it and maybe subsequent people will also get the best out of it, please. And yes, so the feedbacks, and maybe if you have any questions in the next 2 minutes, I'll be happy to answer them. So like I said, like you could check the repo again, the assignments are there. So if there's anything that's also at the end of like the notebook I just covered, if there's anything you don't understand, you could easily talk to us via Telegram and we'll be able to explain anything. So let me just know in the next 2 minutes if you don't have any questions. So we could see, okay, CUDA is like NumPy for GPUs. Yes, we could see, yes, we could say correct, but not 100% correct. It's more of like, yeah, CUDA itself, it's okay. Yeah, maybe we could say that. So I think it's more of like a framework for accessing your GPUs. So yeah. Yes, I could see that to convert. Yes, to convert maybe your numbers to GPU because you have like the CUDA NN, which is like used for CUDA with like deep neural networks. So yes. And because like if you really want to work with CUDA directly, you need to be writing in C programming language. So but with this particular, like with Pytorch, it makes it easy for you to just interface with CUDA and just make everything with other like deep learning frameworks to have that kind of particular interface too. So really nice. So I'm guessing maybe, okay, so there's one question. Let me just answer that and I think we'll be done. We talk about dimensions. What if we are dealing with voice? I haven't really dealt with voice in voice data, honestly, but I would say maybe voice, you would take voice as more of, maybe I would say it's maybe two-dimensional in some case, because let's say you do record a voice and the voice is a long time and you kind of you are measuring some values of maybe spikes, or maybe not two-dimensional in some case, maybe three. Yes, maybe I would say it's three. Maybe depending on, maybe there are maybe various quantities you will find in a voice, and you are measuring also the intensity a long time. So maybe I would say three, because like you would see, like there are some cases where voice data, you kind of apply convolutional neural networks on voice data. But I will just get back to you on this, but I'm assuming, let's say three in most, in the worst case, yes. So really thank you so much. It's really a nice session. So please feel free. So what will the name of the folder and GitHub be for push? Yes, so the GitHub, let me just answer this. So this is like, let's say you clone the repo. Any assignment you do, just store it within this exercise submissions. And you will see this submission template, please. So you could just briefly read it, and inside you tell you how to store the name of your file. So all your assignments will be here within this subfolder. I think I explained briefly in the beginning of the lecture. So yes, so this is just a template, so it's taking some time to load. Okay, so here is just giving you like steps to do when you are creating the repo. So it's really simple, but don't too much worry. We could always go over it again and again, and you could just draw my attention if there's anything that's not clear. And feel free to maybe fork the repo, and if there are any changes that you feel might make the repo better or any mistakes, I'll be very much happy to accept those changes. So really happy to like discuss with you. Sorry, we've gone a bit over time. So if there's anything, just message, feel free, no worries. So we'll also send the form so that we'll recalibrate on how to go about these lectures so that we'll like treat more efficiently. Thank you so much. Thank you. Thank you. Thank you. Thank you. So I'll be ending. Thanks so much.